question. Was there... It looked like there was some sort of, like, Excel program we had to use for, like, half of the preparation. I wasn't quite getting that.
Huh?
Yeah.
Well, there was a link in there that you could click on to get to the Excel spreadsheet,
Mm-hmm.
and then you just opened it up and plugged in the stuff for it.
Oh, okay. Just look that up. Okay.
Like in the lesson instructions, it said the Excel instructions inside of the lesson notes,
Okay.
and then it said the quantitative inferential procedures XLS.
Right.
Did anyone have any questions about the preparation assignment?
Preparation assignment. Just for clarification, so the difference between like a T confidence interval and sample Z confidence interval is just basically like you don't know the sigma for sample T. Like it just seemed like they were like the same
So
thing.
you're using it pretty much is. Just the only difference is instead of using sigma, you're using the standard deviation of the sample size or the sample rather than the standard deviation of the population.
Right. Just kind of make sure. Okay. So, actually, yeah, I do have another question. It's for number 2, for part 2. Is there a formula that you use for finding the 95% confidence interval? Is it like the same thing that the same equation we've been using, or?
It's kind of the same, and so with the other confidence intervals, it looks like. With the confidence interval for the with the t-score included, it's the x bar plus or minus the t-score times the standard deviation over the square root of n.
Okay. T-score. Okay.
And they give you the t-score in this one.
Oh, they do.
For some reason,
yeah, it's the 2.1448.
For some reason, it's not letting me open up the Excel thing this time.
It's not letting you open it?
I'm trying to click enable and editing, and it's not letting me.
That's really weird. It was for me.
Oh, there it is. It's on the next page.
It's the same thing keeps popping up saying.
Which one did you click on?
Hey, Cameron.
Clicked on one?
Yes.
Did you click on the Excel thing?
Sounds great.
Yeah, there's like 3 options, and you just choose the quantitative inferential.
Yeah. Let's see
Why
what
green?
maybe we just
this really what the breeze smells like in Hawaii?
It really does. Okay, so for that problem, for like number 2, the X bar would be. Correct me if I'm wrong. Is it the? Oops, there we go. Like the mean of like 47 years. Is that the X bar for question 2?
Well, the X bar is the stuff you found for number 7 of part 1, where X should have been 46.73 or something like that.
I'll open this time. That's nice.
Oh, for number 1.
Well, part 1. For part 1, the X bar and the mean. And so we should have gotten like 46.73 the X bar, and then standard deviation was like 8.83 or something like that.
So, sorry, you cut out there.
That's all good. For part 1 of number 7, it told you to use the data for the first part of part 2 and find the X bar and the standard deviation of the sample.
Oh, right.
And so you should have gotten like 46.73 and 8.83 or something like that.
Yeah.
And then you just use those numbers for the equations.
Got it. Oh, okay. Wow. Okay, got it. It's all right there.
Okay. Anything else? Are we good?
I think we're good.
Okay. Well,
Let's do this. So number 3, it's just sigma's unknown.
well, I would love to say I can agree with you, but I have no idea what it even looks like yet because my computer's being slow.
That'd be the right thing. It's just asking, like, according to this lesson, what do we assume the standard deviation is?
Well, it can't be the same as the mean.
Well, this time I thought we were learning that the standard deviation, like, you don't know what it is. Trying to find ways around it.
It's when we don't know the standard deviation for the population mean, so we have to calculate the standard deviation for the sample mean.
Go listen to the question when you guys know it out.
Let's see. I think it's we assume sigma is unknown. That's just what I
Yeah.
think. Is that?
That's what I thought.
Got it.
That's good. I just wait for Justin.
Oh my goodness, freaking iLearn load.
I just read question number 4. It's like super easy.
Yeah.
You guys can go on ahead a little bit. I can write it down on a paper until
Okay,
it finally comes up.
that's fine. So number 5.
Well, 4 what we put.
Oh,
That's no, right?
No, yeah. It literally says standard deviation is not known. It asks us, is it known?
Oh, yeah.
Oh, no.
Value of T.
Um, T. So, okay, so what does T stand for exactly?
T stands for the student,
Funky.
like the student's distribution. It's like the it's basically how you find the distribution when you don't have sigma, obviously.
Right. Okay,
So it's more of the sample distribution rather than the population distribution.
got it. So then, okay.
So what was the question for number 5 then?
For
What is
5,
the value
it's
of T?
Or what is the value of T? Okay.
So I think I got 1.5, but let's see.
what did you get?
1.5.
1.5.
What was the X bar
11.
for that one?
11.
Okay, and what was mu?
Well, the thing is, I didn't understand. It says mu is equal to 8, and it's also mu is greater than 8. So I just used 8.
Yeah. Starting with the.
Yeah, because then that's the null hypothesis.
Yeah.
And then the sample standard deviation was
6,
okay. And what was n?
9.
You said 5.
1.5 is what I got.
Okay.
N is 9.
9?
Yeah, 9.
Okay.
Whoops. Okay. I switched my numbers around. Okay. About to get it though.
I got 1.5.
Okay. Is your computer up yet, or are you still loading?
It's still loading, but that's why I had you just give me the numbers.
Yeah. I assume so.
Holy crap, iLearn is of the devil.
Yeah.
Yeah,
Okay.
it goes especially slow when you're on video chat and stuff. I've kind of
Yep.
noticed. Then it times out when you're only like not using it for like 5 minutes.
Now the next one's just a bunch of numbers you have to type in.
Oh, fun.
And they're all super close, so I hope I don't repeat it.
Okay, so what did you guys write for your equation to figure out the value of t? Because I think I plugged the right numbers in.
It's
yeah.
x bar minus mu
Okay.
divided by s divided by the square root of n.
Okay. So it should be 11 minus 8,
Yep.
and then multiplied by 6 over the square root of 9. Or
Yes.
yeah.
6.9.
Yeah. I keep getting different answers. Maybe it's just the way I type. What?
Yeah. 98, 96,
What?
8. There's a problem. 6.6, 7.
Okay, I'm not getting the right answer. Are you supposed
Okay, so it should be 11 minus 8.
Yeah.
You divide that by 6 divided by the square root of 9.
Divide that. Okay, I did not. Yeah. Oopsie daisy. Thank you for that. I was multiplying it. I was like, what the heck? I kept getting like 6 and negative 5. It was. Alright. 1.5. Okay, got it. Alright, cool. Finally. Here's fun.
Find X.
What did you get for x bar? What did you get for number 6?
For me?
Number 6. Have you worked on that one yet or no?
I've got the x bar, but I want to see if I did it right and made sure I got the numbers right, I guess.
I don't know how to find the X, but I'm trying to figure that out.
It's just the average.
Just the average?
Uh-huh.
So the mean?
Yep.
The 98.2.
It's the mean of the sample. The x bar is just the mean of the sample.
Okay, well, the mean I got 98.22.
98.22? Okay, good. That's what I got.
I got that too. Just put the numbers in.
And then S is the standard. No, it's not. Is it the standard deviation? No. S is.
S, yeah, that's the sample standard deviation.
So it's the 0.922.
That's what I got. The
T-score? 47.5. 476.47.
476.407.
You said the
Is that what
T
you guys
score?
think? Yeah.
I don't have that yet. Hold on.
Okay.
Well, I just plugged everything into the Excel thing, and that's what it gave me. So.
I had to shut that computer to actually run.
Oh, really?
So I'm doing it all by. Yeah, my
Okay.
computer's being a lovely piece of equipment.
Yeesh.
The T.84.
What?
For the T score, I got negative 1.84.
Negative 1.84.
Yep.
I don't know how I got that. Oh, I'm
Did
just,
you change the when you in the Excel program? Did you change the there was like a place for the null? Did you put in the null?
oh no. No, I should put in the 98.6, right?
Yeah.
Oh.
Yeah, it gets me the negative.
Then make sure you change that. Well, then you should make sure that it says like that it's less than 98.6.
Make it less.
Because you can change that thing under the null where it says equal to, greater than, or less than.
Right. Hypothesis.
So the T, you got negative 1.842.
Yeah.
Okay. Yeah, after I changed it, that's what I did wrong.
So 98.6 or 0.986.
98.6.
Okay. Type that into the confidence level as 98.6.
Wait, what?
I'm on the Excel sheet.
Okay.
Yeah, so I'm looking at the confidence level
Mhm.
right now in that little box. So I put.
You
Am I
put in
supposed
the
to
null,
put something?
you put in the null hypothesis then at the confidence level.
So what do you put in the null hypothesis box?
98.6.
98.6.
The 98.6. Okay.
Uh-huh. And then you take that long list of numbers and you make sure that's where it says variable 1.
Yeah. And then the confidence level box, is that also 98.6?
You don't change anything in that box.
You don't change anything in that box, okay. So it said like 95 before, so just not.
Yeah, because that's just telling you that you want the 95% confidence level, which is what the A equals 0.05 tells you.
Okay. And then the type of test you put in less than. Is that right?
Yep.
Okay.
Why do you put in less than when it's...
Oh, maybe greater than. Sorry, I misread the cell.
Yeah, it's greater than 7%.
Yeah, I have no idea what that was about, but I can't believe you heard that.
Well, the p-value, I got...
Yeah, mu should be less than 90.6. Because with the null hypothesis, it's mu equal to 98.6, and the alternative hypothesis is that mu is less than 98.6.
So the t-score, I'm getting negative 1.843.
Yep. And the p-value
Okay.
should be 0. Wait, hold on. The p-value should be 0.040.
040.
040.
What did you get?
I got 0.04049.
Okay, that's not what I got.
Yeah, I'm not getting that either.
I'm trying to open up the Excel spreadsheet because the Excel spreadsheet calculates it a little bit differently than the program calculates.
Because the answer you got is if you put in less than, not if you put in the greater than.
Wait, what?
I switched the type of test to less than, and that's the answer you got, is the 0.409. But we're doing greater than, so it's different. So you did it right, you just did it.
Where are you doing greater than? It's supposed to be less than.
Wait, what?
Is it supposed to be less than or greater than?
It's less than. Because mu is less than 90. Because the shape is open towards the number and away from mu.
Okay. Alright, well now I'm getting the 1040. Okay.
So it's 0.04. 0.04?
Yeah, because it was like 0.04049.
Yeah.
So it'd be only 0.04 because we don't need to put second zero.
Okay, 0.04. Okay. Alright. Alright.
Based on that evidence, you should reject the null hypothesis.
Okay. I check the null hypothesis. Okay. So it looks like we're doing the same thing for the next couple questions.
Yes.
So quick question. So how do you tell? How can you tell what type of test you're running? Like less than, greater than, or like not equal to? Like.
Well, that's all based on alternative hypothesis.
It's based on the alternative hypothesis.
Yeah, so like the test you're running for number 11, it says that it's not equal to.
Okay. It's not equal to. Oh, okay. Yeah. All right, cool. Awesome. I think I get it now.
So, what do you guys get for the p-value then?
For 11?
Yeah.
I don't have that. I am very, very slowly still waiting for Excel to open back up.
Right. I got like 3.957, but it's like, oh wait, maybe I didn't put the confidence level in, right?
The mu is not equal to 40, that's the null hypothesis. Isn't it? You put 40 in for the null hypothesis.
Oh, you put 40 in?
Pretty sure I'm asking. Jessica, is that what we do?
Wait, what?
When it says the mu is not equal to 40, is that the null hypothesis you put in as the 40? No.
Well, it says the alternative hypothesis mu is not equal to 40. So when you're doing your test, it should be the x bar, which was like 40.048 minus 40 over your standard deviation. For the p-value, did you get like 0.9952?
Actually, I did. Yeah.
9952?
Yeah, I got 0.9952.
I didn't. Okay, so.
Then again, I'm doing this by hand, so I'm really hoping this is right and not.
So, Cameron, what do you type in the Excel sheet that made it work?
Me?
Yeah.
I'm not even sure if I did this right, but like I put the confidence level and null hypothesis as 40 in both boxes, but and then the type of test.
The confidence level is 40?
Yeah, I mean, I just put it in, but yeah, I'm not really sure.
Did I type the numbers in right then?
Yeah.
I'll check that.
Yeah.
Is that gonna make a difference? It's 9, 14, 37, 62, 68, 2, 59, 157, 27. Oh, wow, there's a lot more that I didn't have. Already.
Oh, did you miss some of the numbers?
Like 10 of them.
Oh, okay.
Okay, so you said 0.995?
Yeah.
That's what I got.
Okay, I didn't have all the numbers in.
Yeah. So would we reject the null hypothesis? Or...
Well, since normally, like, if they don't give you the, like, whether it's the 95% confidence interval or anything like that, you just always at 95.
Mm-hmm.
And so your A value would be equal to 0.05, and 0.995 is way higher than 0.05. So I would fail to reject the null.
Oh, okay.
Unless I'm completely off in my thinking.
Yeah. That sounds good to me.
So is 13 it decreases, doesn't it?
Wait, what?
For 13, if you change it to...
Oh, I'm not even there.
Okay.
I'm trying to copy this and put it in Excel to check it so I can just move it over rather than to retype everything.
So Jay, what did you put for 13? What did you put for the confidence level and null hypothesis in that box? In those boxes.
The only thing I changed was that it's less than instead of the not equal to.
Right.
No, that's it.
I did that too, but what's in those other ones? Because I feel like I'm not putting in the right numbers in, but somehow I'm getting the right numbers.
Well, I just left the confidence level 0.95, which is the typical.
Okay.
And the null hypothesis is set 40.
Null hypothesis at 40?
Yeah, well, it's 40, yeah.
40, okay. Alright. Oh, okay. Makes sense.
So 11 should be 0.996 according to the to Excel, right? For number 11.
For number 11.
196?
Because it said that when it's not equal to 40, the p-value says it's 0.996.
Huh.
Well, with Excel, it says it's
My
0.995.
calculator says 0.995.
Yeah, 0.995.
Yours says 0.9952?
Yeah.
Yeah.
That's what my calculator said, but now it's saying that
Something else.
Yeah.
oh, just kidding. Maybe that's why. Oh, there we go. That's right.
Cool.
I forgot to change the end. 0.995. Okay, now we need to change it to mu is less than 40.
That makes it go down.
Did the p-value increase or decrease? It decreased. And with that decision, you would still fail to reject.
Mhm.
Confidence level of question 13. 11.
And 15, I think it's just the same, but you guys can check.
I think so.
That's the same.
Yeah. Cool. So we're done.
Yeah, I think so.
Let's go over the answers.
I can
Yes.
read them off if you want.
Okay.
All right.
Okay.
So number 3, we assume that sigma is unknown. So
Okay.
okay. 4 is no. What is the value of t? Or number 5 is 1.5.
Okay.
Number 6 is 98.22.
Okay.
S, or I'm sorry, number 7 is 0.922.
Uh-huh.
8 is negative 1.843.
Okay.
9 is 0.04.
Okay.
Mm-hmm.
10, we reject the null hypothesis.
Yep.
11 is 0.995.
Yep.
Yep.
12 is we fail to reject the null hypothesis. 13 decreases.
Yep.
14
Mhm.
fail to reject the null hypothesis.
Yep.
And 15 they are the same.
Cool.
Yep.
Awesome.
Well, let's see how we did. We got 100.
Yes.
Oh, yay.
What would I do without you guys?
That was good.
Yeah. Actually, that Excel isn't too hard to use.
No.
Surprisingly.
It's really not hard to use. You just have to get it to open.
Yeah.
Yeah.
And your computer can't be slow. You know?
Yeah, well, that's my computer.
Yeah. Well, sweet. Hopefully I can do well on the homework, because I always seem to be...
I don't do too well. Man.
Yeah, it's weird. Yesterday I just, got a terrible grade on it. I was like, wow, okay. Great group meeting, and then can't do homework well. But anyway, I'll figure it out.
Yeah.
Well...
Yeah. All right. Well,